Okay, right now we are ready to run the simulation on the model that we already create. Inside the schematic editor, we will take the option compile and open model in HIL SCADA. If you do so, what will happen is that the model will compile and all those messages will appear inside the message area at the schematic editor. But suddenly the HIL SCADA will open. And here in front of you, you have at the left hand side a replica of the HIL SCADA when it's opening the model that you compile, okay? In this case, the HIL SCADA will successfully start, and the first thing that will appear is a window trying to identify the real-time simulator that you will use. If there is a physical real-time simulator, the HIL SCADA will identify and will take the data from there. However, in this case, we are using the virtual device, and what we need to do is use the mouse and select and click at the option load model to the virtual device. Okay. Something that you need to understand is that using the physical device or the physical real-time simulator or using the virtual device, there is not difference. The virtual HIL device is basically an emulation of the real time simulator. The unique difference is that when you use the virtual HIL device, there is not real inputs or outputs from your computer that you can use. That is the only difference between the real hardware device and using the virtual device. Okay, but coming back to my explanation here, we are interested on using the virtual device, and we will select the option load model to the virtual device. What will happen then is that the HIL SCADA will start to load the model inside the environment, and you will see this progress window, okay? At the time that you look this window and you can see in those bars the loading process, you will see at the message window, several messages related with the process of loading the model inside the SCADA, the HIL SCADA, okay? When the process is complete, you will see that everything is configured and ready for you to use this model inside the HIL SCADA environment. And what we need to do now is, well, it's time to create a panel where we will use several devices to show the results of our model when the model is running the simulation, okay? And it's extremely simple. The first step that we need to do is create something called panel. You can imagine a new panel like a white page that you will use to put all your measurement and displaying devices, okay? In this case, I will use, there is a button that say create a new panel. You can use the icon here on the toolbar, or you can use this big icon over here, create a new panel, okay? When you press the icon or you press the button, a new panel will appear. In this case, you will be able to identify an empty area here in the middle. Again, I call that the working area because over there is where we will perform all the important tasks. Okay? In this case, what we are planning to do is the following. If you remember, we have this circuit and we already use manual calculations and we obtain the numerical values for the branch currents I1, I2, and I3. And now what we want to do is use the model that we create inside the schematic editor. And when the simulation runs, we would like to show the numerical values. In this case, we select using a gauge that is a monitoring widget. Okay, the gauge, it will be like an analog clock that is used to show you analog signals. What I'm trying to say is we have our model ready inside the schematic editor, and we are collecting the signals here with those SCADA outputs. And now those signals can be used inside the SCADA, the HIL SCADA, in order to show you the results. Well, let's do the following. Now we need to install some indicators. In this case, we will use the gauge. And what we need to do is click here, drag and drop, and this indicator will appear in your panel. To be honest, this resembles any kind of analog indicator using a needle that we have, for instance, in a very old stereo. Okay? But more important than that is that right now we have an indicator that will help us to show you numerical results using this kind of indicator. When we put the indicator in the panel, there is not connection between the indicator and the signal that we want to show. For that reason, we need to create or establish the connection between signal coming from the model and this indicator. The process is extremely simple. What we need to do is double click at the indicator and the property editor will appear. You will see this window over here, and there is a section that say analog signal. In this case, this indicator is specifically designed for analog signal. And when we create the model inside the schematic, we use a SCADA output that is collecting analog signals. What we need to do is, from the schematic, we are planning to use the SCADA output that is sending the signal to the SCADA and use that signal and make the connection with the indicator. And the connection is made here at the analog signal. We will select IA1, and that is the name of the current measurement that you use at the schematic editor. And right now we establish the connection. Right now we establish connection between the analog signal that is coming from the model, and this indicator will show the numerical value of that signal using the indicator. The next step is test and see if this is working. And to do that is extremely simple. The HIL SCADA has a button here at the top that allows you to start the simulation. When you press that button, the simulation will start, and you will see here below that the time starts to move, and also you can see that the virtual HIL mode is enabled. But more important is that you will see the numerical value of the signal presented at the indicator. And over there, as you can see, the indicator is showing 1 amps. That is the current that is going through the current measurement device inside our model. In this case, the maximum value of the scale is 100. It's too high. We want to reduce the size of that scale, and that is very simple. We can define a maximum number for that scale by double clicking at the indicator and advanced settings, setting up the maximum value to 2 ohms. When we confirm that change by pressing OK, what will happen now is that the maximum value was reduced from 100 to 2, and the indicator is showing you 1 amps. And right now we got very nice results, because if you remember, the current measurement is located here near to the voltage source, 15 volts, and that is recording or measuring the current I1, and the numerical solution was 1 amps. Right now, we are confirming at least that the current I1, the branch current I1, the numerical value that we obtained at the analytical calculation was 1 amp. And right now, using the real-time simulator, using the Virtual HIL device, we confirm that the current is the same 1 amp, okay? Now you can do some other configurations, like including a new name for the indicator, in this case I1, and including some description. I speed up a bit the implementation, and I include 2 more indicators, one for the current I2 and one for the current I3. Now we have the 3 currents here at the panel, and right now we can see the numerical results. And just for simple comparison, current I1, 1 amps, current I2, 1 amps, and finally current I3, 0. We are demonstrating that the model that we create inside the Virtual HIL device is producing the same numerical results that the model that we solve by classical circuit analysis theory. Okay? There are a few more options that we can do in order to improve the presentation of our model, and one of them is that you can include comments in the way of a text note. If you go inside the library, there is an option for text note. You drag and drop, and then you edit, and you will be able to include a very customized note over there. In this case, I include a small note that say, my first Virtual HIL model, mesh analysis, DC steady state. Okay? There are more options that you can use to improve the quality of your panel, including images and so on, but we will be covering those topics later in future videos. Here, this is the final implementation. I insert an image over here for the circuit in order that you can identify this is the current I1, I2, and I3, okay? At this moment, we are ready to close, but I would like to tell you that we finally implement an example, very basic example inside the Virtual HIL device using Typhoon HIL Control Centre. We use the schematic editor and we build the model. And we use also the SCADA, the HIL SCADA, to collect the signals and to show the signal. At the very end, what I would like to say is we use a very basic example. Yes, we did. But this example is just to show you the basic workflow that you need to use inside the Typhoon HIL Control Center in order to create a model and run that model and get results. You need to use two important applications, the schematic, and inside the schematic you will create your electrical circuit using different components. You will add measurement devices to collect signals and then signal processing devices to send those signals from the model to the HIL SCADA. When the signals arrive to the HIL SCADA, you are able to run your system and create panel to show numerical results during the simulation. Okay? We did that. We took a very basic circuit. We create the circuit. Those SCADA outputs, they are collecting the signal, analog signals, I1, I2, and I3. And when the model is running, we can access those signals and show in some indicators or display the numerical results. We finish here just saying that the workflow inside the Typhoon HIL Control Center is very simple. It's very intuitive and very friendly and will allow you to be familiar with the basic functionalities. I use a very basic circuit. Please don't criticize myself for using a very basic circuit. The idea is this example is not about learning circuit analysis. All of you know more about circuit analysis, but the idea here is to understand the workflow that you need to follow inside the Typhoon HIL Control Center. Finally, I would like to say that I have a GitHub repository and you can follow this link and go there. And there is a folder called real time. Inside that folder, you will find all the files developed during this video. Also, if you go to my research gate, there is a link over there. You will find a document showing you step-by-step explanation about this. This document is located inside my repository called Research on Real Time. Well, I highly invite you to go download the documents and start to play with the Virtual HIL. For me, it's been a pleasure. It's been a very important video today. This is the first example that we are running, creating from scratch a system and running the simulation using the Typhoon HIL Control Center and the Virtual HIL device. Well, that's all for today. Thank you very much for watching. I will see you at the next video. Bye now.